So this question is a little bit more complicated than some of the ones that we may have seen in the past. It says that a block slides down a frictionless plane that makes an angle of 30 degrees with the horizontal. The acceleration of the block is what? All right, this is if you've taken physics before, these are the infamous ramp problems. It says that we have a ramp. It's got an angle of 30 degrees. It makes a 30-degree angle with horizontal. And we're going to put some block on it that slides down with some mass m. Hopefully I don't need it, but let's see if we can't figure this out. So I have a picture. I'm going to draw a free body diagram. And my free body diagram is going to add up all of my forces and see if I can't figure out what my acceleration is. So I know that girth still pulls on this block with a weight force in the downward direction. I know that this block has a normal force pointing on it. And the normal force is perpendicular to the ramp. By definition, a normal force points perpendicular or normal. We use the mathematical term normal to describe a normal force. But the normal force points perpendicular, orthogonal to the surface. So I drew it in this direction. All right, so I have a picture, I have a free body diagram. In order for me to use Newton's second law, F gives me an acceleration, a net force gives me an acceleration, I need to know a coordinate system. And here is the trick. On many, many ramp problems, you don't want to use a traditional acceleration. Traditional coordinate system that looks like this. This will work. It'll just make your life much more difficult. So I'm going to choose a different coordinate system this time. I'm going to choose a coordinate system that is actually aligned along the ramp. So I'm going to say positive x is down the ramp and positive y is out of the ramp. And there's no reason for you to believe that I should even begin to do this. Other than I've done these problems before and I know that this one's going to make our life easy. So let's see why this works. All right, so again, I have both an x component and a y component to do this. So I need my sigma f in the x direction is going to give me an acceleration in the x direction. And similar, I'm going to start with a y direction. I'll add up all my forces in the y direction. It's going to give me acceleration in the y direction. Okay, so let's look at the x direction. Okay, the x direction says we need to add up all of our forces in the x direction. So I'm going to start here, go around. I hit a normal force. The normal force is only in the y direction, so there is no x component of this in my rotated coordinate system. However, when I get to the weight force, I see that there is an x component of the weight force. And it's a positive value because it points down the ramp, and down the ramp is positive as I've drawn it. And this is going to give me, those are my only forces, my normal force and my weight force are my only forces. It's going to give me an acceleration in the x direction. Well, it'd be really nice if I know what this value is. This is mg in the x direction. I haven't taken into account that it's not fully mg, it's just mg in the x direction. It's going to be giving me m times a in the x direction. All right, let's see if we can't, I don't know. Let's see if we can get by without using the y direction. There is something that I will say on the y direction. I know that my acceleration is equal to 0 in the y direction because it's sliding down the ramp. So this is actually a reason why I want to do this problem this way, is because the normal force, or not the normal force, sorry, in the y direction, our forces have to add up to be 0. All right, so let's go back and do more on the x direction. The problem I'm having is I don't know if my coordinate system looks like this, and I have a weight force that points in the downward direction, I want to know what is the component of the weight force in the x direction. And I'll want a component of the weight force in the y direction. Well, I need to know which angle is the right one to use, or what trig function is the right one to use. So if I look at this triangle right here, I will see that this is theta. This is 90 minus theta, which means this angle right here has to be theta again. So if this angle is theta, that angle is theta. So I'm going to expand this picture. I have my weight force in the y direction. I have my true weight force in the downward direction. And I have my weight force in the x direction. That is theta. So when I look at the x directions again, I'm going to skip here and jump down over here. I have mg, my weight force, times, I want the x component, but the x component is the opposite. So sine of theta is going to be ma in the x direction. This sine, even though I'm looking for the x component, it's a sine value because the angle they gave us, and because of our shifted coordinate system, it turns into being this trig function has to be a sine. So when we go through and plug everything in, we'll see that mass cancels with mass. We're left with g sine of theta. Theta is 30 degrees. So 9.8 times sine of 30 degrees, and sine of 30 degrees is 1/2. Meters per second squared is my acceleration in the x direction. There's no acceleration in the y direction because we're only accelerating down the ramp. So that means half of g is going to be 4.9 meters per second squared, and it goes down the ramp. So I've used a combination of a shifted coordinate system to make that term to be 0, which means my acceleration is only in the x direction. It also meant that my only force in the x direction was my x component of my weight force, and I used a couple extra pictures to make sure that I checked my trig function to make sure I get the right trig function. I get the sine, not the cosine.